completely factor the following trinomial, negative 4x squared y minus 4x cubed plus 24xy squared. We look at this polynomial and maybe our first impression is to get a little scared because there's x's and there's y's going on, and we say, oh, that's hard to do. But we also look at it and say, oh, look, I got a 4, I got another 4, I got a 24, which is a multiple of 4. I have an x here, an x there, an x there. I can factor a 4x out of each of these three terms right away. That's simple to do. It'll give us something a little bit easier to work with. Since I commonly don't like leading order terms that have a negative in them, why don't I actually factor out, instead of just a 4x, why don't I take out a negative 4x? And let's see what we have left. I take a negative 4x out of this. I'm left with one of those x's, and I'm left with that y. I take a negative 4x out of this. The negative 4 goes away, so I have a positive now. One of those x's went away. I have an x squared. Take a negative 4x out of this. Negative 4 out of a positive 24 leaves me with a negative 6. Take out that x. I have a y squared there. So now I have a trinomial, still some x's and y's, but I don't have such big coefficients, so that's nice. Let's go ahead and reorder this. I usually like to have things in a descending powers of either x or y. Why don't we put this in descending powers of x so that this highest order term has a coefficient of 1 on it. All right. So here's a polynomial in descending orders of x, or a coefficient, leading order coefficient of 1. So one way that I can figure out what the factoring of this remaining bit is if I look at the quote-unquote constant term. This doesn't look like a constant term because there's a y in there, but if I'm thinking about this as a polynomial in x, I have a coefficient of x, I have a coefficient of x squared, I have a coefficient of x, and then I have stuff without any x's. So this plays the role of that constant term. So if I look at this thing and figure out factors of this that sum up to the coefficient of x, we'll have our factoring. All right, if I want factors of this to sum to something with a y in it, that means my two factors, one of them is going to have a y, the other one's going to have a y. Right? I'm not going to have a constant and a y squared times each other because that sum is never going to end up with just a y. So I want my factors both to have a y as part of them, and then I'll look at factors of minus 6 and try and get them to sum up to a positive 1. Right? And I know that some factors of negative 6 that sum to a positive 1 are a positive 3 and a negative 2. So positive 3y times negative 2y gives me a negative 6y squared. The sum of these two things is a positive y, so that's what I want. So let's write that down. So this factorization, right, just like with a polynomial that instead of y's here had some more numbers, this factorization of this polynomial descending powers of x, the leading coefficient of 1 is x, and then write down one of those factors, plus 3y, times x, write down the other factor, negative 2y, and here is our factorization. Right, if we feel a little nervous about that, we can always check this by foiling it back out. I presume the part that would make us nervous was this step, so let's just FOIL out this part, ignore the negative 4x for now, and make sure that's right. X times x gives me our x squared. 3y times negative 2y gives me our negative 6y squared. Here's a 3yx, so we get a 3yx. Here's a x times negative 2y, so we get a negative 2yx. We add those bits together and we see that yes, indeed, we get that term. So this checks.